We are going to start, and I'm Rich Krieg, Mary Lasky sitting here. We don't have two chairs up here because we're going to rotate a little bit. We decided we'd just give ourselves a little bit of background instead of me introducing her and she introducing me. Be kind of hokey. But I am in the political science department at Texas State University. And my background has not been in Texas. My background is in healthcare and public health. I was commissioner of health for the city of Chicago, running the health department there, which provided patient services to about 1 million Chicago residents, plus the mainstream public health services. But I also worked for 4 years for the Metropolitan Chicago Healthcare Council, which is the Association of Chicago Hospitals. One of our critical infrastructure sectors is healthcare and public health, so I guess I'm one of the few people that's worked on both sides of the ledger. I also worked in health philanthropy for many years and came to these issues of critical infrastructure about 5 years ago after doing several FEMA projects in the National Capital Region in the area of terrorism and nuclear detonation and how that would affect health of Washington residents and so on. Here's what we're going to talk about today. I'm going to go over the critical infrastructure area. What is it? What are the issues that surround it? Why is it important to us as citizens of this country? I'm going to talk about the Journal of Critical Infrastructure Policy, which I am editor of. It's a new journal that Policy Studies Organization, who's running this meeting, has started. And I'll go through what we aim to do with that journal. I was in the Journal of Science Research and Governance meeting this morning, the first one, and they said their journal is 10 years old, so it's an infant. So since our first issue is coming out in May of 2020, I guess we're in the second trimester of pregnancy. We're not born yet. But I will briefly go over the journal and what we, as I said, what we intend to accomplish with that. Mary will come up and talk about Powering Through, Building Critical Infrastructure Resilience, which is a book that her organization, the InfraGard National Disaster Resilience Council, is going to be publishing. And then I will talk about the healthcare and public health sector. I actually wrote chapter 7 of that book, so I'll take a little bit deeper dive into that. In talking about today, we just want to, have an open floor. If there's any question at any point, or if you want to raise an issue, we will have time for questions at the end. But anything, everything that you'd like to comment on, just raise your hands and we'd be happy to respond, either of us.
My brain is already fried, okay? In this context of constant change, how you define and keep a definition of critical infrastructure stable is already beyond me.
I will try to cover some of those definitional things, and in fact, that is an issue that's affected policy because people will slice and dice it in different ways. But I think we're going to give you the definitions that I think are probably the most productive in terms of policy setting and responding to emergencies. So here they are. Great segue. We usually deal with 16 critical infrastructure sectors. These are, the major, you could call them macro systems: energy, water supply, healthcare, public health, telecommunications, that are considered essential for society to function. And they affect national security, they affect economic activity, and so on. Each of these sectors sometimes is called a socio-technical system. And that's because we have, the wires and the generators and the switches and all of the kind of engineering functionalities. But you also have expert knowledge, people who are doing this work, user behavior, social acceptance of these technologies, and the policy. And policy is done by people. So that dimension of it is very, very important. If you have a disaster, for example, in the healthcare sector, will nurses, if the school shut down, will nurses come into the hospital if they have kids at home? There are very important issues like that.
Do you have some definitional rule that says that infrastructure does not include systems made up primarily of humans?
What? Of humans?
Do you have some definitional rule that says that infrastructure does not include systems made up primarily of humans?
No, not at all. In fact, for each of these sectors, I think I'll get into that when I talk about healthcare and public health. That's the one that I think I can draw it out. But for all of these, whether you're responding to a cyber attack, whether you're sensitive to a threat, whether you're devising a strategy as a emergency response person or an emergency manager, people are what matters. You know, there was a meeting in room 1 on artificial intelligence, and I don't think artificial intelligence will make the day when it comes to some of the threats that we experience.
Education is not up there, for example, and education is a system made up primarily of humans. I'm not talking about systems that don't operate on human systems or need humans to operate.
Yeah.
I'm talking systems.
Well, these have actually been set up in law. And yes, in other words, these are codified by law, but it's not to denigrate any of the social systems that exist. Let me give you an example. We did a project in Howard County, Maryland, which is Howard County is about 25 miles from the White House as the crow flies. And in this work, as I mentioned, we looked at a 10 kiloton nuclear detonation in the mall in Washington. And Savage, which is and Laurel are on the southern flank of Howard County, and the fallout could go that far. And we work with school administrators. We work with particularly the assistant principals, because they stand up the school emergency response plans. And we develop procedures and guidelines of what to expect in that kind of a situation. And what we're pushing for is that for the threats that exist, we want community resilience to be the foremost denominator. We talk about community resilience as the way to survive these systems going down. Okay, I'll get more into it later. Your comment is very appropriate, but these are the areas that the federal government has laid out as those sectors. Could you put in schools? Yes. Could you put in retail, pharmacy? Yes. But these are the major constellations of facilities that are around the world considered critical infrastructure. To make this to fry our brains even more, CISA, which is the looks at critical infrastructure, cybersecurity and critical infrastructure security, also looks at about 55 cross-cutting functions that happen, okay? And these functions have to do with distribution, management, supply, and connection of these different systems. And so it's not the static 16 sectors that I talked about before, but how these sectors hook up together. All of these sectors connect. And
educate and train is up there.
yes, that was under, where is it?
Manage.
Under manage, okay. Educate and train, great. So these are important because you can look at threats across the sectors and look for the weak spots that need to be hardened. It's very important. Food, how does food get from the suppliers to the local level? Food, pharmacy, just-in-time inventory, where pharmacies may have, a 2-week supply. Your supermarket may have a 2-day supply. How do you analyze that? How do you compensate when these systems go down? And just to give you an example of how they're connected, the New York blackout, the Great Blackout in New York, which occurred 2 years before 9/11, some trees in Ohio touched a power line in Ohio. That led to a sequence of events where on the eastern seaboard, for 2 weeks, the electric went out. Arthur Andersen, the company, calculated that $6.4 billion was lost. Those interconnections happened. There was a little bit of human failure in there, but and of course the electricity connects with hospitals and manufacturing and all those things, the financial sector. So it's great that these systems connect, but those cross-setting functions make them all reliant on each other. It's very complex, but we have to look at this because there are tremendous vulnerabilities built in.
Does your analysis of critical infrastructure only look at threats, or do you also seek opportunities?
We seek opportunities and threats.
And threats.
typical SWOT analysis. And there are strengths, but there are tremendous weaknesses that we all have to be cognizant of. Let's look at these threats. Think back to 1993. There were 14 million people connected to the internet in 1993. And what happened is many of these infrastructure sectors, you call them legacy sectors, okay? And they are, you know, they are old, many of them, old hospitals, old components of the electric grid, on which an overlay of digital equipment has been placed. And some of that's planned, sometimes it's unplanned. But in those years, we've had tremendous proliferation of the connectivity at the same time that technology has been changing at an exponential rate. So we have these growing sectors that have physical organizations, they have equipment, they have people, and some of them have built-in vulnerabilities. So we may not be talking about a terrorist, but it's the simple fact that they are so complex and so unwieldy in many instances that in itself becomes a threat to the system. The cascading failures are of extreme importance because, you know, if you think of the typical hospital and the electric gear in a hospital, if we have a lapse in water, we have a lapse in electricity, hospitals are at extreme risk, as I'll talk about later. Physical and cyber attacks. When you talk to electricity providers, they will often give you a figure like we have 10,000 incursions, cyber incursions, per day in our system. A tremendous amount of movement in. The Idaho National Lab, back in, I think it was about 6 years ago, did something called the Aurora experiment. It's more than 6 years ago. But they demonstrated that with a cyber attack, you can basically shut down an electric utility. Not just turn it off, but also cause great damage to it. And adversaries are out there, both on the physical side. We've had physical attacks on our power grid. One in my state of Texas. They're more often than you would think. And you have a growing number of cyber attacks. You have equipment-related attacks, equipment that engineers would know more about than the people who work on cyber in an institution because they're behind the firewall. But someone could affect the pressure or the temperature gauge on a hospital boiler, for example, or furnace, and cause an explosion. And that's one little example of what could happen in the boiler system. The ones that are really alarming are those that are natural disaster threats. We all know about the ones that are occurring right now. I've now been to the annual Space Weather Conference in Boulder, Colorado every year. And there's concern about what's called a coronal mass ejection or sunspot activities, solar storms. Back in 55, I think?
59.
59, okay, I was a couple of years off. There was what was called the Carrington event, which was a full-bore solar storm that hit the Earth. Back then, the wires of the telegraph system, the telegraph keys, which are heavy equipment, some of them started to go on fire. The wires went down. Several years ago, sunspot activity hit where Earth was 6 days before. So the Earth was going its orbit around the sun, came out. And the space scientists really believe it's a question of when. It's not a question of if. And were that to happen, and it was a major solar storm, you're talking about not just large systems, but small electronics that could be affected. The other concern is just the military people call it asymmetric warfare. Both state actors, non-state actors. If you loft a relatively small nuclear device in the upper atmosphere, that could cause an electromagnetic pulse. There are differences in terms of the threat level for that. I've been to so many meetings where there are differences, but essentially there's agreement that were that to happen, depending on the altitude and the force of it, it would cause major damage here to the extent that the electric system would not be repairable. And we're talking about long-term lapse of electric services and all of the other things that would happen with that. Korea has two geosynchronous satellites in orbit above the United States that could have small nuclear weapon in them. Some people think that that's the case. I heard a general in a meeting I was in several weeks ago here in Washington talk about that. But these are some of the things that could happen. And were that to occur, when you do exercises with first responders and with emergency managers, it's very clear that within a question of weeks, you have a major societal breakdown. Just takes weeks. When you go out to 3 weeks to 4 weeks, it's hard to imagine how people would survive in conditions of no electricity because of the way we provision food and safety and security and all of the other things that we come to expect. Critical infrastructure policy, very quickly, I say here it's bracketed. In 25 years, President Clinton did an executive order in 1996 where for the first time critical infrastructure was looked at. There was the so-called Marsh Commission named after its chairman that started looking at critical infrastructure. And then President Trump, in March of this year, did an executive order on electromagnetic pulse. Anytime we look at these issues, the reason it's so complicated is that you have different dimensions. In the vertical dimension, you have federal, state, and local. You also have public and private. Most of the electric companies are private providers. And you also have another dimension of engineering science, and then on the other side, pretty complicated policy. So it's kind of like three-dimensional chess. And when you look at any issue, you have to take these all into account. The electric grid, electromagnetic pulse is a good example of this complexity because you have an executive order, and that executive order put the National Security Council for the first time in charge, so to speak, of federal government activity and preparing for electromagnetic pulse. But it's at the state level where much of the work has to be done on the electric grid. And in Texas, we've had a couple of legislative sessions recently where the legislature did not pass very simple hardening recommendations. So you have to work at all the different levels to make progress on these.
May I say?
Yes, ma'am.
That different levels must now include regional and local, because there are functional things going on at the regional level, for example, in transportation, which you need to be involved in to manage what goes on in transportation.
That is prescient. In our first issue of the Journal for Critical Infrastructure Policy, we will have an article on how regional approaches are essential. If you're the mayor of a city and you have to deal with these breakdowns, they may go into Canada, the systems that you're dealing with, and they will definitely go into the adjoining states. So regional approaches are absolutely necessary. We have to rethink that. And you do have models of regional planning and regional transportation authorities that you could look at. The difficult part is that each one of these infrastructures has a different jurisdictional perimeter, so to speak. But despite that, we have to move in that direction, or we're almost powerless to look across these sectors and even assess the vulnerability. So we have to look at regional governance. Absolutely.
A Canadian power distribution failure that caused the other great blackout in 1977.
Absolutely. Yeah. Yeah.
Yeah. In New York.
Yes.
Yeah.
It goes across, and that was one of the reasons I sought out an individual to be on an editorial board who's up in Canada. We'd like to involve them in some of the discussions we plan to have. So regional is where it's at, truly.
Even when you go global, regional is where it's at.
Yeah, yeah. If you want to raise that later, I could talk about some of the global things going on. Again, I mentioned this, the majority of critical asset organizations are controlled by private entities. I haven't gotten a good number in the electric area, but some people think it's as high as 85% of the electric infrastructure is in the private sector hands. And what you've got there is the public good, which may call for hardening, and particularly when you're repairing the grid or putting in a new component, at that point the cost to harden or to make it more resilient is far less than if you retrofit. And at that point, utilities have to think about do they do that? And they become less competitive. If they do that, they're thinking of their shareholders. They're privately held companies in most instances.
And they're regulated rates, right?
Correct.
So another neat variable, we're now getting into co-generating electricity, solar cells everywhere.
Yes.
Right? That probably makes this interesting too. Can I have some solar cells that bring down the power grid?
Absolutely. Some of the kind of trendsetters in the utilities are interested in that. I'll talk a little bit about microgrids on the health part, but in fact, that is one of the areas that you have to look at. One of the aspects of that that's very important is that they also be EMP protected, not just that they're co-generating electricity and they can start storing electricity and put electric power back into the grid, which is one of the functions of a microgrid, that they be protected against some of the threats that they have. Very good points.
Do we have a redundancy approach to the critical infrastructure? So you say that there are blasts that can take out your electrical system. Do we have a layer of, or do we have an option that's independent of the existing grid? So if you have solar systems that are being distributed on the existing grid, is that a good idea? Or are we thinking about how to layer the system somewhat such that there's independence of alternatives?
Yes, it's not one size fits all. It's all of the things you're implying. One that's extraordinarily important is to have a grid that's resilient in terms of withstanding some of these attacks, whether it's cyber, whether it's an electromagnetic pulse. I've been to many meetings, talked to many scientists who specialize in this, and that's essential. The other is to have islanded systems with microgrids where you can know that if that grid goes down, you're going to be resilient. You're storing energy. You have an alternative energy source like solar, and when the grid's not down, you're putting electricity back in the grid, which can help them during peak periods. There's a lot of work going on in this that I could talk more about, but these are great points. And then I'm not going to read this, but as I mentioned before, the policy arena is very complex here. That's not to say that we can't make progress. And now is the time, as these systems become more complex, as they're more vulnerable, as we understand them more, this is a time to really put some ideas on the table and get ideas not just from the engineers, but also from those who look at community resilience and those who respond to emergencies and those who are in government, because it's all too easy not to think about this. And to the extent that we lose time, we're really putting ourselves in a very, very bad position. Last thing I'll talk about is the journal itself. I have more of these if anyone's interested, but we're very excited about this because we've gathered together about 25 people who are some of the top people in the field. They're not just engineers who work on this. We have for example, two journal editors in the engineering area wanted to join our board because there has to be a policy focus if we're going to advance the agenda of making communities and systems more resilient. We have people working in government. We have Chuck Bean, who's the head of the Metropolitan Washington Council of Governments, is on. We have his counterpart in Houston, Texas. We have people who have worked on these systems and others who have worked more in the field of community resilience, emergency responders. So it's a fabulous group of people. To a person interested in how it is that we can advance policy in this area, get the necessary funding, do it in an objective way, and mostly bring people to the table who may have ideas to do cross-fertilization between all of the individuals. So the areas we cover, which are on that first page, which I can't read and you probably can't, but basically we want to look at the policy level, we want to look at the systems level, what systems innovations have the power to have transformative effect in resiliency. We want to look at specifically at community resiliency, which is the third area. And the last area is emergency management, emergency response. 6 months before Hurricane Harvey struck, we did a tabletop exercise for emergency managers, emergency responders, health people, the Coast Guard, in the TranStar building, which is Harris County, Houston, Texas's Emergency Operations Center. And we put them through it. We had one of the foremost experts talk about what is a coronal mass ejection, what's the probability. They asked a lot of questions about it. And then we worked for about a half a day. You know, what would be the impact on your systems? Nobody knew about this stuff. I mean, they understand there's an electric grid, but they really don't understand the consequences if that happens. How do you restart equipment in a hospital? What equipment would function and what equipment would not function? How does this accord with our emergency response plans and our protocols? Like I've seen in other areas where you deal with these major catastrophic types of issues, emergency responders want to know more. They need to know more. They have to train on this. Leave it up to them in terms of how much of a priority is in their geographic area. It's something that we have to work on, so I'm glad we're doing emergency management in this as well. So May 20th, May 2020 is our first issue coming out. We'll have 2 issues a year. It's published by Policy Studies Organization. We made a decision to have it be open access, so it's not the kind of journal that is on paper that goes out to members of an association. It's going to be available to you all and to the public and to operators and owners. And we're going to do it in such a way that it's not just academic articles, but really trying to hone in, zero in on the policy issues, what are alternative perspectives, how do we solve these problems? Going back to what you said, how do we build up resilience at the community level? You know, what is it that we need to know as far as our schools and our, what makes for a resilient community? And how do you move in that direction? So basically now I am going to stop, and Mary's going to talk about powering through.
So in recent disasters, one of the things that has happened in recent disasters is that they've been very costly. So they've been costly not only in the amount of money, but in the lives lost also. So there's a great reason to then think about what are we going to do to make this world more protected, more resilient, and not have these huge costs. I was just amazed that it's on an average from 1980 to the present, it's an average $42 billion because of problems that we've had. So really interesting. So part of I'll now introduce myself. I'm Mary Lasky. I'm at the Johns Hopkins Applied Physics Lab, which is halfway between here and Baltimore. It is a part of the university. It's now off by itself. We do work in space. We do work for the military also. That's where we started. And we're doing a lot with Homeland Security now and with medical kind of things too. So it's a broad kind of organization that does things in a wide way. I started out in the information technology world, and so led our central information technology for quite a while. And when 9/11 happened, it was, oh, Mary has experience with disasters, so in IT, so let's bring her in. And soon I was running what we called our business continuity plans on how to do this. So I went from kind of one disaster to another disaster, and started off with, simple disasters like what happens in a hurricane. And the person that I worked with, an assistant director in operations, read the book, The Great Influenza of 1918, and my life changed because she handed me the book and said, make us secure. And then it went from that into what happens with, what if there is an a nuclear attack on Washington, D.C., and so really working on that. And that, I mean, it seems to get worse and worse, you know, from pandemic to a nuclear attack. And then it was like, well, what happens if our electric power goes out? And so that seems like everything is based on that, which I will talk about in a minute. But that led me to being part of something called InfraGuard, which is a public-private partnership with the FBI. And soon I was very involved with that. And it started off called the Electromagnetic Pulse Special Interest Group. And from the very beginning, it was doing much more than electromagnetic pulses. In fact, the first exercises were done on cyber. So it was always broad. And now we've gotten the name in order to really reflect that, which is the National Disaster Resilience Council. And we have published, we've held as part of the DuPont Summit for many years until last year, and published our proceedings here with the Policy Studies Organization. And we then published in 2015 something called the Power Grid Triple Threat Exercise Book, which the triple threat was cyber, a solar weather, a solar storm, and the third was an electromagnetic pulse. So those were the three things that we did. Then in 2016, we published a book called Powering Through From Fragile Infrastructures to Community Resilience. And that was kind of a broad brush kind of thing. It had one chapter on critical infrastructures. It had one chapter on what does the community do to maybe be an island and work as a group kind of thing. So it was a broad brush kind of thing. And now we're working on, and it will be published in 2020, a book called Powering Through. We love that name, so we've decided it's the Powering Through series. And this one is on building critical infrastructure resilience. And so that's what's going on there. The new book asks three particular questions. What happens to this particular critical infrastructure if the electric grid goes down? And then the second question is, how can this particular critical infrastructure help the electric power get back on? And then the third question is, what can they do now to be more resilient? So those are the three basic questions. Just so that everybody in the room kind of knows about this is a picture of where the electric grid is. And there's an eastern interconnect, there's the western interconnect, and of course, Texas has its own power grid. And as you can see, this goes on up into the eastern, and the western go on up into Canada. So it's really tied together. So the book does not handle all of the 16 critical infrastructures, although there's in energy, it covers a couple of the different critical infrastructures there. And these are the ones that we cover. Plus the national, when you talk about emergency management, it's so tied in with what happens with the National Guard that we have a chapter on the National Guard, because understanding when the Guard can come and help and when they can't come and help is another important part of the understanding of all of this. So we look at this whole situation with our critical infrastructures thinking that the foundation is really our electric power. And if that goes out, we're in serious trouble. But also tied with that is communications. And the electric grid can't get back up if we don't have communications. We can't have communications unless we have power grid back up. So this is kind of an interesting thing. And then we put kind of 4 basic pillars because if we don't have water, we can't sustain as a human race. We also need food, maybe not as critically as water as it turns out, but we still need food. And we need transportation. The whole situation here with our supply chain is really based on this, and then emergency management and police and the first responders that are keeping us safe and when crisis that comes. This is not to say that any of the other critical things aren't important. In fact, there's cuts of all of this saying the critical lifelines. And so that also includes our health care, et cetera. So there are various cuts that we take of the critical infrastructures. But water, I just mentioned, is so important. And in fact, here is health care. Within 2 hours, if they don't have water, they're in a situation that is really critical. But also at the Applied Physics Lab, we did an exercise, which actually all of our people that were in it really thought that this was a very good exercise, because we said, what if there was one water main that came into the laboratory? And we said, what if there was a water main break and we didn't have water? And we found out, because of the sprinkler systems, et cetera, you have to close in 2 or 3 hours, even if you aren't a hospital and affected by this, because you're not allowed by law to keep open if you can't, if you don't have water in the sprinkler systems, et cetera. So water becomes just such a critical part of all of this.
We just ran that exercise not so long ago at a certain naval base.
Ah,
It wasn't an exercise.
well,
Everybody had to go home in a few hours.
yes. Well, I mean, if you really turn it off, one of the things that happened with the laboratory is we said, okay, there's one water main. This is one critical point, and so let's have another path in as well. So those are things that, doing exercises can help you concentrate on things. Mm-hmm. So one of the new things that we have in the book is something called Notional Charts. And this really goes about how do you move from where you are today, where you might not be resilient, to being resilient, and what are the critical things that you need to do in order to be resilient. So in here, one of the issues is who pays, and that is one of those things that Rich kind of talked about in a variety of ways, because with the electric grid, there's the federal structure. There's something called the Federal Regulatory Commission. Then also on nuclear power, there's the Nuclear Regulatory Commission. And then there is this called NERC, and it goes on to the states, and the states have various ways of doing it, of public policy kind of things. And there's stockholders, and so it's very complex about how to do it. And the main question is, if you're going to go and improve things, make it cyber protected, make it so that it won't be subject to solar storms or to something like that, then you have to ask the question, who pays? Is this, the utilities say, hey, if it's national security, that means the military needs to pay. The military goes, no, that's a private thing. By law, we're not allowed to touch this kind of thing. So no, we're not going to pay. And then the stockholders, because you flip the switch and it's always on, maybe not in California right now, but normally for us right now, we can flip the switch and we have it there. So the people don't want to pay more. And so how is that going to happen? And can we get block grants? Can we have, like there was for all of the solar and wind as it came in, they had tax incentives to do it. So are those answers, et cetera. So those are some of the interesting policy questions and that don't follow into the technology, etc. In water, our notional chart actually tends to be more complex. And Rich is going to talk a lot about microgrids, but having backup generators, having microgrids, et cetera, in our water systems could help a lot. So that's going on. So we have food and agriculture. One of the things that happened in 2008 is we decided as a nation that we would no longer have warehouses with food grain, so that we dispersed it. And so we no longer have great supplies as a nation, which is kind of unsettling, and it would be good if we had. But there are also some studies done that says there's enough food in the pipeline that maybe we would be okay. So there's some issues here about what do we need to do. Holland is one of those countries that's very small, and they've become a great exporter of food because they've created greenhouses and are able to grow a lot of crops and do it very efficiently. And now they're exporting food. So that's an interesting thing. Transportation is one of those that's also key. And one of the important things there is that trains all move because there is an electric system of controlling where they go and how they go. If you were to take and turn off all of the stoplights here in the city, what would be happening? It could be mass bedlam kind of thing. Maybe it would actually work better in some of my thoughts, because we would be courteous about you can go and then I can go and then you can go and I can go. And so there are some questions there, but it could cause mass panic if the transportation fails. With cyber, one of the things that has happened is Rich talked about the fact that in our critical infrastructures, there's a lot of various components to it. And let's just take water. There are gauges that say, pump this water. And there's things, oh, too much water, turn it down. And so it's all regulated. And those kind of things are called industrial control systems. The industrial control systems for most of our critical infrastructure are very old. They're analog systems, but the people who manage them go, oh, if those controls were on the internet, I could sit at home and worry about whether this is up or down or whatever. So let's put all of this on the internet. Well, then that makes everything more vulnerable. And so one of the things that we're suggesting is that you don't have all of this connected to the internet, because maybe it makes it easier for the people around to manage it, but the vulnerability is great. So that is part of the things going on. So I'm going to turn it back to Rich to talk about more in depth one of the chapters in the book.
Mary, I have an observation.
Oh, okay. Fine.
About infrastructure networks.
Mm-hmm.
And the question is, to what extent do the people involved in managing, creating these networks think in terms of integrating the networks themselves? So for example, we have water problems, water vulnerability. Well, there are pipelines that carry water, and there are pipelines that carry other things, gas.
Yes.
To what extent are our pipelines generalizable? And can they be used for one thing or another depending on the need?
Well, that's a very interesting question, and I don't think that anybody is asking that question. I've never heard it before.
Really?
And because one of the critical things, and this maybe maybe everybody will say, this is gross, but our wastewater system is really important. And if we don't have that working well, we will have diseases rampant. And with the wastewater system, within a few hours, if it's not pumping water through this, then the pipes will freeze and they become like concrete. And therefore, they can't be restarted and they can't be reused.
So I'm not so sure I like the fact that I asked that question.
I didn't think so. But could we use the current pipelines to do something else if that were to happen? That would seem to me to be a really interesting question.
It's happening in one area, and it is a very good question. PRM, which is one of the largest utilities in the Carolinas on the Eastern Seaboard, is working with the gas companies out there using geomapping. So for the first time, you're superimposing the electric lines and the gas pipelines. And it's interesting how they diverge, how they come together, but it's in both their interests to understand the distribution of that. Again, back to your question on regional scale, this is what we have to start doing, and so that we understand not only the complementary aspects, but also what are the aspects that threaten us more. But that work is starting now, and like Mary, I've not heard of other areas where we're trying to
There's one
double
where
up.
it really needs to happen, and
Yeah,
that is
thank you.
it's a critical infrastructure also, that is in cyber manpower. What you're looking for in this area is the skills, the techniques, not the institutions. The United States obviously has all the skills and techniques that it needs to have a very sophisticated cybersecurity infrastructure. But it's not clear to me that all of the elements, all that capability is linked in a way that would make it useful in conduction of cyber warfare. There's a lot of talk about cyber warfare, but I'm not clear that there's an integration mindset in the area of cyber infrastructure that includes accessing all the technical skills that the nation has at its disposal.
There are two very welcome developments, some going back a while. In 2002, when George W. Bush, after 9/11, set up the Department of Homeland Security, critical infrastructure was just sort of coming into its own. I think in 2014, it was mentioned 67 times in the appropriations bill for DHS. And through DHS, each one of those 16 categories has groups all over the country. They're broken out by state. So for cyber, you have groups meeting in every part of the country. And then Mary mentioned InfraGard, to which we're both members, which is a sister program of the FBI. How many people are in InfraGard now across the country?
61,000.
So you have 61,000. Mary's group, the National Disaster Resilience Council, has 2,000 or something like that. So those thousands, tens of thousands of people break out by areas like cyber, and they produce a strategic plan, some better than others. So you have one for dams, but in the cyber area, to its credit, the Department of Homeland Security said we need a bottom down, but we also a top down, but we need a bottom up. And working in the health sector group, as I'm in Austin, Texas, some pretty, and all of this information safeguarded because it's an FBI program. So there are databases that occur. There's best practice transfer. So if you're working in dam security / cyber, you're hooking up with others who have had experiences. So that's happening. So both from the federal policy side and then through this FBI program, there's a lot of cross-fertilization. Is it enough? No. These things change at an exponential rate, but it's better than what existed just 2 short decades ago. So that buoys me up, gives me some hope. I'm going to switch to health now and go through these very quickly. It's one of the largest sectors that we have. It's a huge sector. Over 6,000 registered hospitals nationwide. Of those, we have 170 VA medical centers. I have that map there. These are, they're called critical access hospitals. I just put that one graphic in from the chapter. These are small hospitals, mostly rural, that have less than 200 beds. And I want to go back to some of the questions about how these infrastructures hook up and what Mary said about water. As Mary said, NIAC, the National Infrastructure Advisory Council, which is a private sector group that's named by, I think it's presidential or congressional order. So that's another example of sectors coming together. They determined that 2 hours without water, hospital goes down quicker than any other sector, okay? Now when you look at these small hospitals, we have 253 counties in Texas. That's the largest number of counties in the country. We have a lot of small hospitals and a lot of small municipal water systems. Now, you all know the water tanks in many of these small towns. They hold about 24 hours of water, okay? How does the water get up to the tank? An electric pump. Now, few have backup generators, and some even have natural gas backup, but they're 1 in 1,000. There's no I can't quantify that. But just imagine if you're in a small town and the electric goes out for an extended period, you only have 24 hours of water, so your hospital is going down. So the question is, are hospitals working with their municipal water providers? Are they involving them in the planning? There is some movement there, and there are some guidelines there. But we have to really have a much more aggressive agenda, both in terms of water and wastewater in hospitals, because of that. And sometimes we're in a flood, Katrina, and water abounds, but there's no drinking water. So that type of planning, although it's outside the sphere of what hospitals do with all of their technical innovations and electric gear, is extremely important. And then down below, it's healthcare and public health, and much of my background's in public health, and so much of this chapter is on the public health sector. We have 2,800 local health departments, and I can't remember who asked the question before, but healthcare coalitions. What I'm interested in are, if that electric goes down, who's going to stand up basic health services? Who's going to be there? Who's going to come out and provide a modicum of health support in these communities? I'll talk a little bit more about that. This is just sort of the guidance I used to write the chapter, to anticipate as best I could the failures that would occur in the provision of healthcare, and to recommend solutions that would reduce morbidity and mortality. And I looked at both healthcare and public health, short-term, long-term, which were the questions that Mary asked of all the authors, and then which were energy-related and non-energy related. I will just say on this that the U.S. has more power outages than any developed nation on Earth. We're talking about industrialized countries. The Joint Commission on Hospital Accreditation requires 96-hour hospital backup 24/7 and to available life support within 10 seconds.
Why do we have more than anybody else?
That's a very good question. Talking about industrialized countries, okay? More modern infrastructure. Much of our system is legacy. Well, we invented electricity. We put up the first telegraph wires. We invented the telephone. Old systems, really old systems that are in disrepair, much like our bridges and our roadways. The newly industrialized countries are investing huge amounts, as we should be doing, in these systems, not just critical infrastructure, all infrastructure, bridges.
So we don't have a maintenance mindset.
I think we have a maintenance mindset, but it's kind of like, if you have a condo association with 6 units in it, 3 of those people are wanting to do preventive maintenance. The other group will only fix things when they break. So when you have an economy like we have, if you start getting in advance of that curve, your rates as an electric provider will go up. And in many parts of the country, you can pick your electric provider based on how much the kilowatt hour costs. So we have disincentives for doing this. So it really does, and this is, again, the reason for our journal. We want to put these questions front and center, and not just what we do in the journal, but around the journal. We want to have meetings so that policymakers can capture the import of this. Right now, in our Congress, we have some leaders, but it's not a time where you can advance some of these issues. But we have to. We have no choice. I don't want to make it seem unduly pessimistic. From looking across these sectors, I see lots of movement. But you're all going to die within 2 weeks. No.
Seriously, though, design complex public systems and in some cases with international partners.
Yes.
One of the things that comes into stark relief in that is that our culture as a whole in the U.S. is not prevention oriented. And you've got to fight to invest in prevention. Just what you guys are doing is a failure modes and effect analysis. We would call that if we were building a space shuttle. That's one of the first things that gets cut on the budgets.
No kidding.
You know? And so, and in your case, you're doing this on systems that they never did that to begin with because they kind of grew. So it's a cultural dynamic here that you're up against.
It is. You got to look at, I don't know if you call them catalysts or drivers. Right in Texas, I'm in Austin, San Antonio. You've got you have Joint Base San Antonio, one of the largest military bases. Where do they get their electricity? They get it from the grid, much of it, not all of it. And the military there is working very closely with San Antonio to have a more resilient electric grid. It's coming from the military side.
Yeah.
That happens all over the country. So I see these green lights going on, and those notional charts in the book, I think were done in a very respectful kind of way in terms of the barriers that we have in the policy arena. Hopefully this will not be a case where we have a large cascading failure that's 10 times worse than Katrina because we don't have electricity for 2 months or more. That often happens. We've all seen that. It's not a maintenance mindset that we have in this country. It's more that if there's a crisis, we'll be very ingenious in how to get out of that crisis. We also will have a tremendous outpouring of help from the region. But almost by definition, you know, Ohio, tree hits cable, no electricity in New York. Almost by definition, everything's going down at once. And again, as I said, with this just-in-time resourcing we have for food and commodities and things like that, you can't be too optimistic. But I do see movement. I'm not just saying it. You know, and there's no choice. We have to do it, or we're not going to survive. It's that serious.
Are you in touch with EEI about this stuff? They do a lot of policy stuff. I mean,
Yeah, we are.
You are in
Through
touch with them.
NDRC.
They know what you know?
Yes, they know what we know. But EEI.
And what are they doing about it?
Well,
Edison Electric, the industry association for the.
it's an industry organization, and so they're caught with the same kind of things of who's gonna pay. And so that's the huge issue, and so, there's concern about that, and there is not a, since they represent the utilities, they're not going to move out on these kind of things. But we've seen action.
Clarify, it's investor-owned utilities. EEI
Yes.
is investor-owned, profit maximizing entity versus some of these NRCA, rural co-op. There's a lot of different types of utilities and operating models.
Yeah.
Public powers are, you know, they're their own customers and stuff. They don't really have shareholders to report to. They would probably be more aggressive in sort of implementing
And
some of
who's
these.
their industry association?
The American Public Power Association. Then there's the National Rural Electric Cooperative Association.
All these people.
Yeah, so it's just,
But-
there's different business models which also have different incentives and
Right.
decision making.
And there is movement in some of the really big utilities. CenterPoint Energy in Texas has looked at the floods that happened in Texas and said, because of these floods that happened, we need to take certain actions, and therefore, let's do all hazard kind of things. So they've built that into their rates of really solving all hazards, so that they can put in cyber, they can put in electromagnetic pulses or geometric pulses. So
Just to, are you waiting for the next?
No, I came to catch the very, very end.
Oh, okay. I thought you
Oh,
might be
okay.
the presenter for the next one.
No,
Okay.
could be.
But just to highlight what Mary's saying, CenterPoint Energy is owned by the city of San Antonio, which is kind of an unusual model. Ultimately, what's the answer here? The federal government does have to step in. We do have to cost out. We need to come up with some innovative incentive finance mechanisms that are actionable and will be accepted by the public. We have to do a good job with public. We really have to raise these issues up to the level. And you know, I'll close out on the hospitals here. Just go to the last slide. But basically, have people in their communities think, in your mind's eye, imagine your hospital. Imagine if the hospital shuts down, how are you going to survive with your kids? What's going to happen with your family? We have to bring it down to that level. I'm just going to finish up here. I'm not going to talk as much about the resilient microgrids. I will tell you that most hospitals have diesel power, 2 weeks of diesel power. After that, depending on the contingency, they're going to run out of diesel power.
2 whole weeks, my goodness.
Yes, and there are many of them old diesel equipment. There's nothing wrong with old diesel equipment if it's maintained and they're run on a schedule and maintained. In fact, some might even be better. But you know, in any field like this, you have people who are in advance of the curve, and basically, we have a situation where healthcare providers have another incentive for wanting to get microgrids into their systems, and that is the quality of the electricity. Cleveland right now has a very ambitious project to set up the Cleveland microgrid in the core of Cleveland, part of Cleveland, but a big part of Cleveland. And they have 3 rate levels, and the highest rate, I think it was like 15 cents per kilowatt hour, pretty expensive. And hospitals wanted to pay that extra amount because they do not want their equipment going down. And that system was reliable 99.69s. It came out to like 4 minutes a year of downtime for that microgrid created electricity. They wanted that. Information system companies wanted that. Financial companies, consulting firms. So there is a market for this, but ultimately we have to get kind of policy planning that's practicable, where you know, the government's taking a lead role. So I'm hoping that some of these issues, as time goes on, really get into the forefront. It may take a breakdown. We're seeing what's happening out in California now. People are much more cognizant of how their houses and homes and lives are affected by these systems. So hopefully we'll reach critical mass and we'll see some movement. I wanted to talk finally about a couple of the recommendations I made that are tied in with other movement in the country. One is that my feeling is that we need to have, and remember, we're talking about continuity of government. If our systems go down, how do we keep our government functioning under those conditions? If the electric goes out, and one of them, it would be a system, a regional array of EMP-protected anchor hospitals. The criteria for setting them up might be near a military base, near a major population center. It might be an academic medical center, but that we pilot this concept. And there is some work going on at Johns Hopkins in this area, but my feeling is we have to start talking about regional centers that can both model what they're doing, but also spring into action in the event that the worst happens. And so that's something that I call for. And then last, with our health departments, and this fits in with many of the long-term goals that the major public health organizations have planned for a number of years, and that is that health departments start thinking about activating in emergencies better than they now do. Many health departments think about the mainstream public health functions, restaurant inspection. They think about other important types of activities. But based on training in public health schools and why they went into the profession and the skill sets that they have and knowledge of community, my feeling is that public health practitioners in all of those local and state health departments should be talking about what happens if the worst happens. Mm-hmm. How will they stand up? Mm-hmm. And then the second part of that is we have 520 regional health coalitions. These are health coalitions paid for by the federal government. Their budget is about $600 million a year. It comes in under the Assistant Secretary of the Department of Health and Human Services. And my feeling is, based on how And about half of them are run by health departments and about half by hospitals. They're in the leadership structure. But the people who populate those regional health coalitions are people who are volunteering in their communities, physicians who have interest in this, nurse practitioners, and so on. And my feeling is that they should, in conjunction with Red Cross and other groups on the ground, they should train and talk about what happens in a 3-week power outage. What happens? How can you activate? How do you triage people? What kinds of services are low cost? How can you communicate without electricity in your community? It all goes back to something that I think she's writing now, but what would you mention about resilience? We have to talk about how do we get resilience, even if these things never happen, to the extent that we work together on resilient communities because we face this common danger. I think there are a lot of types of residual benefits that happen. And I make these recommendations based on movements in these fields and the thought that there will be a sufficient number of people to at least pilot test some of these concepts. Okay? These are typically not going to be cases where people come in helicopters and bring in the food and bring in the supplies, and where the hospital's there. It's just going to be something where we have to talk beforehand in the event these happen. Okay? So that's the end of our presentation. Yes, ma'am.
Can we have access to your slides, both of you?
I believe so. I think
And how would we do that?
we'll have to check. I don't know
Well,
if
why
there's...
don't you just give us your email addresses now so we can ask?
Sure.
Because each of
Well,
us individually.
what's this?
Assume responsibility.
There you go.
See, we wouldn't
Modern
have that if we didn't have it. There we go. There we go. Wait a minute. R-K,
You're just,
R, I can't write.
Take a
R,
picture of it.
K. Oh, I wouldn't be able to see that on my
Yeah.
phone. K-R-E-I.
No, I before E except after C.
Thank you.
Thank you so much, everybody.
Thank you.
Appreciate your coming.